What's up, my mathletes? That's right, Miss Muscarella coming at you. And in this video, we're going to take a look at part 3 of graphing the absolute value functions, equations, and inequalities. So let's go ahead and get those notes out. Here we go. Now, we've already taken notes on part 1, and part 2 had to do with the transformations compared to the parent function. And now we're actually going to get into graphing some of these. So when you do these, when you take a look at these, there's going to be 3 key steps, all right? And the very first key step is that you want to find and plot the vertex. All right, that's going to be the very, very first thing. So the vertex is key of identifying, and remember that is going to come from the h and k values. So those two values are going to give you the vertex. And remember, that opposite and same. So opposite refers to this value right here. Whatever's in there, you got to take the opposite of the sign, so you'll see why a little bit. And then the same is going to refer to the k value. Whatever the k value is, that'll be the same. Once we have that, the next thing that we take a look at is the a value. So that a value is going to tell us 2 things, right? It's going to tell us whether it opens up or down. And then the other thing it tells us, and I'm going to put a little plus here for and, up and down, and these slopes. All right, so there's going to be 2 slopes that the a value will tell us about, and that is step 3, follow the slope in both a positive and negative direction. All right, so those are going to be the 3 key features when you go to plot an absolute value function from the equation. Now, when we take a look at increasing and decreasing, so these are going to be some words that are going to be associated with slope. So a increasing interval is going to be like a positive slope, and a decreasing interval is going to be like a negative slope. So when you look at the general slant of a line, you know, that's a negative, it will go down like that, whereas a positive slope would go up. So those are going to be a couple of things here. Now let's go ahead and graph, if we will, generally the 2 types of absolute value functions. So over here, I want you to just write down 2 guys right here. So one is going to be the upside down v, and the other one is going to be the right side up v. Now, when you take a look at these, I want you to look at this side right here, and this side right there. So both of those, generally speaking, have what kind of slope? Hopefully, you said the word positive. All right, so anytime you have a positive slope, that's going to be increasing. And I'm just going to abbreviate that INC for increasing. So when your y values are getting higher, when they're getting taller, that is going to be the increase. All right, so when you have an increasing interval, then that's where your slant of the line is positive. Now, similarly, when you have a decreasing interval, when your interval is decreasing, that's when your slopes are going to be negative. And both of those, you would just classify that. I'm just going to write it once here, but that would be the decreasing interval when you do that. And a note about increasing and decreasing intervals when you do that, and this, I want you to make sure you write this down. So a little big bonus tip point here. Always soft brackets. All right, and we'll do that as we go through here. So soft brackets are going to look like parentheses. And what's confusing about it for a lot of people is sometimes they think it's an XY coordinate, and it's not. So we'll play with that here shortly. So we're going to take a look at these 2 examples here and talk about all these different pieces. Now the vertex, remember, we got to flip the h value. So the h value right here is -1, so we've got to flip that, and that's going to be 1. And then the k value we keep the same, so that's 3. So the vertex is 1, 3. So I'm going to go over to 1 and up 3 and 1, 2, 3. Put a dot right there. So that's my vertex. Now the opening. So I look at the a value for the opening. And when I look here at that opening, that a value, that piece is positive. So that tells me, generally speaking, that is going to open up. And the value for a, of course, is 2. So that means my 2 slopes are going to be 2 and -2. So -2 and 2. So from the vertex, I'm going to have this general shape where it opens up, and I'm going to have a slope of -2 and 2. And remember, slope is rise over run, so that would be -2 over 1 and 2 over 1. So from the vertex, I'm going to go up 2 to the left one, and up 2 to the right one, and then that's all it can fit on this one. So then I would draw my little arrows, and that would be the picture that represents this. Now the AOS, and this is very, very important here, when you do the AOS, you're going to look at the H value, because the H value is going to give you the AOS, and in this case our H value is 1. Now here's a technical writing thing. If you just put 1, no point for you, bro. You gotta write like a mathematician. And the AOS is going to be a vertical line, x equals, and in this case, x equals 1. So notice, if we were to draw that, we're gonna go over to 1, and we're gonna put a little dash line that goes down here. So that splits the graph in half. So if you notice the distance from the, any point on the left side and the right side, they're gonna be the same space from that vertical line, from the AOS. So when you write that, be sure to write x equals. Otherwise, no point for you. Sorry, go cry me a river. All right, so that's one of those little things, technical writing, you got to be solid with. Now, domain and range. And this is where it gets really, really interesting. So the domain is going to be all real numbers. And you'll notate that like this and this. That's the interval notation for all real numbers. Now, when you take a look at the range. So the range has to do with the y values. Now the y values, notice where the y values start from. So they start right here at 3. That's where it starts. And notice this opens up. So 3 is my lowest y value, and then I keep going up forever and ever and ever and ever. So when you go up on the y-axis, my values get higher, and it goes to infinity and beyond. So it goes all the way up there. So my range is going to be from 3 to infinity. Now, here's the thing you got to be careful of. The infinities always get soft brackets. But the range, whatever that value is, that y value is of the vertex, that will have a hard bracket, always. Now, I want you to add in these pieces here, because we're going to talk about these. So if you wanted to talk about the increasing part and the decreasing part. So we're going to add these 2 intervals in here, because we're going to be doing some things in there later. And I'm going to look at this left side here first. I want to make sure that my colors here are the same. So if I look at the left side, notice how this is going down like that. So that's going to be the decreasing part. So, and then the right side is going to be the increasing part. So those are the parts that kind of come in there where I have a negative slope and a positive slope. And sometimes people will actually write that on the graph. They'll write DEC for decreasing and then INC for increasing. Now, when you take a look at the intervals for these, and this is where I like to think of the x-axis. So that vertical line that we came up with, that's going to be at 1, at x equals 1. All the way on the left, if I count from 1 to 0 to -1 and go all the way out, I'm going to go all the way to negative infinity. Then I'm going to go from 1 all the way to infinity. So this is kind of like the x-axis, only lower. Now the increasing part and the decreasing part. So when I look at my picture and I see the slope for increasing as from 1 on, I'm like, oh, okay. So I write from 1 to infinity. Because that is this side right here, that's my increasing side. And you can see that there on the graph. Now my decreasing side is going to be this side from 1 to negative infinity. So when I look at that, then I would just simply write that as negative infinity. Because you're going from left to right, negative infinity to 1. And that would be the decreasing side. So those are going to be a couple things that we'll take a look at, as we go throughout the course for lots of things. So positive and negative slope, that's how you want to think about that. Now, the dilation and reflection, remember they deal with the A value. All right, both of those are the A value. So if I look at that, what were the ways that we described the dilation, either more of a stretch or narrow. And this one, we're going to, because the A value is 2, we're going to have a vertical stretch of 2, because that deals with whatever that A value was. That's your A value right there. Now, the reflection, does it reflect over the x-axis? Is it below the x-axis? No, it's not. So that's just plain old no. Now, the horizontal shift, remember, that is going to look at the H value. Notice the parent function is actually the vertex. I'm going to put a little dot right here. The vertex would be right there at the origin. So this, and you look at the H value, the AOS, that value is 1 unit to the right. So the H value, that horizontal shift, we go to the right one. So right one. And then the vertical shift, that's the K value, and the K value is 3. And so you have to use the words up and then how many units? Up 3. So when you talk about the horizontal and vertical shift, you have to use the words left, right, up, and down. All right, so that's a little bit about example number 1. Now, if you think you got it and you like, I got this, I can graph this, then pause the video and go ahead and do example number 2 completely on your own. All right, and we'll come back when you're ready. For those of you who are ready to do this, let's go ahead and talk about this guy. All right, so here we go. So the vertex, remember I have to flip and keep the same. So with that being in the middle, my vertex is going to be at the spots 1, -2, 1, -1. So I want to keep the y value, whatever the k is, and I want to flip the sign of the h value to get that, which means my opening, and notice I'm going to look at the a value for the opening. This one, the a value is this guy, so that is -3, so that's going to open down. So you can either write the word up or down, or maybe just draw that V. So when you describe that, you can do either. So we can do up or down, or draw this symbol that would represent that. Now the AOS, remember, that is going to be the h value, which we got as -3. So when we have that, or I'm sorry, -2, so remember, you're going to write x equals -2. So whatever that h value is, you're going to go over to -2, maybe draw that dashed line, and then we're going to plot the vertex, right? Plot the vertex, -2, -1, so that's right here. Boom. Now, when we have a value for -3, so my 2 slopes there, generally it's going to go down. So my 2 slopes are going to be -3 and +3. So -3 over 1 and +3 over 1, because both of those would reduce down to 3. So my 2 slopes, I'm going to go down 1, 2, 3. And when I say down, I mean from the vertex. So down 1, 2, 3 from the vertex over 1. And I would keep going down 1, 2, 3 over 1, but that's off the graph. And then down 3 over 1 again, and down 3 over 1 again. And there you go. So that would be my picture for this one. Now the domain, again, domain for all absolute value functions is always all reals. So from -infinity to infinity with soft brackets. Now the range, this one goes from the bottom, so this one goes down. And anytime you have an absolute value function that is shaped like this, your range will be from -infinity all the way up to whatever the k value is. And the k value, we look at our vertex, that's just that y value right there, and the k value is -1. Now, when you do that, be sure to put a hard bracket on the -1 and a soft bracket on the -infinity. Now let's take a look at our increasing, decreasing parts again. So INC, DEC, and when I look at these, I can see, and this again, you may want to write this on your paper. So that left side, that's where we increase. So you can say, oh, we're going to increase on the left side. So that goes from -infinity all the way up to the x value of our AOS, or the x value of the vertex, which is -2. And soft bracket's always on increase and decrease. And then the other piece, the decrease, so over on this side will be decreasing, and that is going to go from -2 all the way to the right to infinity, again with soft brackets. So that's the increase, decrease, domain and range, vertex opening, and a value of a for all these. Now when we look at this one, the a value, is -3. And this we got to be careful. Even though there's a vertical stretch here, you don't say by -3. So I'm just going to abbreviate vertical stretch, VS. So there's a vertical stretch, but it's still the positive a value. Whatever that a value is, when you describe the dilation, it's always going to be positive when you talk about that. Now the reflection, does this one go over the x-axis? So yes, so reflection is over the x-axis. Over x-axis, because it is below the x-axis. Now the horizontal shift, again, when we take a look at the AOS, that is 2 units to the right, or I'm sorry, to the left of the line y equals 0, x equals 0. So we're going to go to the right 2, and then the vertical shift, we actually went down 1. And so notice those coordinates, 2, 1, they kind of sort of make up the coordinates for the vertex. So those are some pieces that you're going to want to pay attention to. So that's a general idea of how to graph the absolute value functions and talk about all those pieces with increasing, decreasing, finding your 2 slopes, locating the vertex and the AOS, and graphing them accordingly. All right, we got one more piece to this one, and I will catch up with you guys when we take a look at that one. Until then, peace out and make it a great day.